Okay, hello together. Maybe you know this. During a conversation between two design engineers, this question came up. Why is there suddenly a GSM module in our motorbike? Answer: of course, it's a modification. Today, changes are the actual everyday design routine. There are bug fixes, extensions, innovations, and much more. This leads to the requirements of how changes in the product development process can be documented in a sustainable and traceable manner. In today's complex product world, changes always involve the interaction of different design disciplines. In addition to mechanical design, other disciplines such as electrical equipment, electronic components, and software programs or modules are also involved. Each of these design disciplines have very specific requirements for a change process that must be supported and synchronized. This is where modern product data management systems, so-called PLM systems, as well as discipline-specific work-in-progress systems came into play. The PLM system is the consolidation level in which all design data are brought together. In the WIP systems, on the other hand, the specific tasks and processes of the specialists in the individual design departments are processed. In today's presentation, we will introduce you an integrated change request management with the PLM system Windchill from PTC and the WIP system DS-E3 from Zuken. Today, we welcome Mr. Markus Fleckenstein from PTC, who will introduce us to the process modules for change request management in Windchill. Hello, Markus, if you would like to introduce yourself.
Hi Markus, and a warm welcome to all attendees. So my name is Markus Fleckenstein, I'm from PTC, and I'm presenting today the Windchill component, or the PLM component in this joint showcase that we have developed. We are looking really forward to demonstrate how we can integrate multiple systems in an overarching change process. So it was very interesting and had a lot of fun over the last days and weeks to build this up. So very keen to present this to you. So enjoy our session.
Fine, thank you very much. So, now a short introduction of the storyline of today's presentation. In a theoretical example, we want to present an innovation as a reason for changing a motorbike. A request comes from the marketing department to offer a service to temporarily increase the performance of a motorbike for a weekend. To implement this innovation, a GSM module is needed in the motorbike to enable more engine power remotely controlled by software. To process this change request, modifications in the engine control unit, in the main wiring harness, and in the software are required. So, how does a typical change request process look like, going through different stages and stations? At the beginning, the green milestones in the left upper corner, the innovation request is submitted in the PLM system. Then the discipline-specific change orders are created and transferred to the individual WIP systems of the design departments. Once the change order has arrived in the electrical design department, the blue milestones, it is divided into further sub-change orders and assigned to the corresponding specialists. The specialists process the sub-change orders and complete them. Once all sub-change orders have been processed, the project manager checks them again and completes the primary discipline-specific change order. The data and documents are automatically updated and transferred to the PLM system. Here, the transition from the WIP system to the PLM system takes place again. In the PLM system, all returned changes are now consolidated and the change requests are completed. So, I now hand over to our partner, Markus Fleckenstein, who will initiate the change request process in the PLM system Windchill with the innovation request.
So now let's start on our racetrack for the implementation of such an example change that we just described. So we will start with a product innovation request that we used where we used a normal Windchill object to create this kind of innovation request that we want to further proceed. And we can see there are many of them for review, and for this specific one we talked about the additional power upgrade as described earlier as a theoretical example, which requires some updates on some components and some products. Probably that's why we included also a change request already. So it seems it's already progressed a little bit. Someone moved this innovation request further so that we can now have this change request, which is then officially proposing solutions and estimating efforts and so on. In the next step, we will take this change request and further detail this out, because from the change request we will move into a change notice, so basically the execution of the change. And this is already prepared because we don't want to have this as a typing exercise here. It should be a demonstration on how this all works together. So therefore we have already prepared a little implementation plan which goes through all the different disciplines. So software disciplines, so there might be need for a new software version. You probably need to have additional cable routing and harness changes. We need to probably add a space in the mechanical design for this control unit, and we also need to modify and update the control unit to add this GSM module. And then we have the different tasks that can be defined and can be further detailed, right? So including which design tool they should be used, or is there a review required, and also some more detailed description information. For example, that we need to modify the harness. This could include some pictures, some text, whatever you might need on the expert system side, like on the DS-E3, to further work on that. So also resulting objects, affected objects can be handed over so that this is then all available for the electromechanical designer to work on his job and to further detail this out basically in the expert system, which we will see then later. Right, so even for where we can have this control unit, this has resulting objects included, but like in this case we just described that the further detailing might be required on the expert system side, right? So really brings everything together. Affected resulting object can be prepared, can be handed over, and as soon as the implementation plan is completed, we can send the whole implementation plan or the whole change notice for execution. Though that means currently it's just planned, so we need to submit it. So the submission takes place, so it moves from open to implementation, and we used a little workflow in the background using our ThingWorx flow to send information to the Zuken interfaces so that they are triggered and they can then identify what additional information is needed, and using their integration capabilities to pull all that information in the relevant system. And with that, let's move on to the specific disciplines. So handing this over to Zuken and see how on the Zuken side this all progresses.
Let's now move to the discipline-specific WIP system DS-E3. In the next step, the sub-change task of the change order 430 from the PLM system Windchill will be created. First, a task for changing the circuit diagram is added. The task number is assigned and the name and description text of what has to be done are entered. Then the sub-change task is assigned to the responsible person for the circuit diagram. Next, the sub-change task for the wiring harness extension is created. Again, the task description is stored and assigned to the wiring harness expert. Now all sub-change tasks are created in the WIP system DS-E3 and have the status in work. Now we come to the realization of the sub-change tasks. The project manager has an overview of all primary change requests and their status. If the schematic designer logs on to DS-E3, only the change requests assigned to the designer are displayed. As next, the circuit diagram is edited in DS-E3. For this purpose, the devices and connectors for the GSM module are added to the circuit diagram. In this extension, the connectors X900, X902 and X901 are added. After the circuit diagram has been checked in again, the sub-change task can be completed by the designer. Now, the expert in charge of the wiring harness diagram logs on to DS-E3 and again gets his assigned change requests displayed. Then the wiring harness is extended in the E3 project in order to apply the changes from the circuit diagram here as well. The check-in saves the changes in DS-E3 again. Afterwards, this change request is also completed by the expert. Let's complete the primary change order. Finally, the project manager logs in to check the status of the sub-change tasks. Using the filter function, the related orders can be found quickly and easily. Once all sub-change tasks have been completed, the primary change order can also be closed. The DS-E3 module document generator then creates the documentation and updates the bill of material. Once this has been successfully completed, the documents and the bill of material are transferred to the PLM system Windchill. The PLM interface of DS-E3 is used for this transfer. The change order is now completed in the electrical design department. And I hand over again to Markus Fleckenstein from PTC.
We have now seen that all the different tasks on the DS-E3 side are completed. The BOMs are updated and transferred, so that we just have a look on the status on the Windchill side. So what is our change process doing here? So we now get a task to audit the change itself, so to see if everything is complete. Normally we do review all the impacted objects, review all the different change tasks for completion and so on, but we will keep this quite short and trust that our colleagues have done everything right, and we will simply complete this task and accept that everything is done. So from that, the whole task or the whole change process will now be completed, and from this we can now review that all these different related objects have also been completed. So the change notice for sure itself has been completed because all the states of the implementation plan task are completed, as you can see. So this has been resolved. So looking into the change request that was created earlier, everything is resolved, as you can see here. And this change request was driven from this innovation request, and also this is now resolved. So that means all the related objects are automatically informed that the change has been completed and that everything has been done successfully. Though that means in this example we have seen how easy it was to connect multiple worlds, in this case using a change process, so really helps then to speed up this change process. And the result on the Windchill side is then a full bill of material, so including all mechatronic components, and so really bringing together mechanical electrical design, and so support across department collaboration, and really enables their better products, faster processes, and then having a consistent view on my complete product itself. So thanks a lot. It was a pleasure with you, Markus, to prepare this showcase and this presentation. Thanks a lot for having me here, and if there's any questions, for sure, feel free to reach out to us and let us know.
Okay, thank you very much. Let us now summarize this presentation. Today we have seen how a change request passes through different stages and is processed. In the process, different requirements arise in each processing stage, which are supported in an optimized way by the specific IT systems. With the work-in-progress systems DS-E3 and DS-CR from Zuken, we offer engineering data management systems which are perfectly adapted to the requirements in electrical design, harness design, or PCB development. In addition to the DS systems, integration modules are available with which the design processes can be seamlessly connected with the PLM system Windchill. Then thank you very much from our side. Thanks also to the company PTC and especially to Markus Fleckenstein for the good and professional support of this presentation. And with that, back to our host, Mrs. Neckning.